Standard 8, subject geography, local time and standard time. We get up early in the morning, brush our teeth, take a bath, then we have breakfast and go to school. We study in our classroom. We return home. We go to the playground to play in the evening. We have dinner, brush our teeth and go to sleep. So here we keep doing similar activities throughout the day. So, which is the most important thing we should know in order to carry out these activities? Yes, that important thing is time. With the help of time, we carry out these activities. But in olden days, how people used to measure time? In olden days, people used to take help of various tools and also depend on various natural events for measurement of time. On the basis of observation and experience, they divided the day into following parts. That is, from sunrise to sunset, it will be daytime, and from sunset to the next sunrise will be night time. The duration from one sunrise to the next will be considered as a whole day. Earlier, natural events and instruments like sun timer, shadow, etc. were used to tell time. So, in this lesson, we are going to learn about local time and standard time. As we know, Earth rotates from west to east. As a result, we experience sunrise, noon, sunset, and midnight. Now, in this, as we can see that there are two parts. First part, that is on your right hand side, is experiencing light. And on the other hand, that is towards your left, they are experiencing darkness. This is because during rotation, the longitude that faces the sun experiences sunrise, and the other, which is in the darkness, experiences sunset. You must have traveled in a bus or car. We often see that trees, electric poles, building, etc. outside from the window. They appear to be moving in opposite direction. Means we are moving ahead and trees, electric poles, etc. are moving behind. Now here, as you can see that here the vehicle is moving towards right side and the buildings, electric poles are moving towards left side, that is behind. Actually, these buildings and electric poles are stationary, means not moving. It is we who are moving forward. Now, as you can see in the right picture, that the sun is moving from east to west and the earth is not moving. Now look in the left picture. You will notice that the sun is not moving, but earth is moving from west to east. Now from these two pictures, which is the correct one? Yes, the correct picture is where the sun is not moving and the earth is moving from west to east. Because of the rotation of the earth, we feel that the sun is changing its position from east to west. But it is the earth who is rotating and the sun is stationary. Okay, now first let us revise what is latitude and longitude. So here in the left hand side, as you can see that latitude are like a shape of a rings, where rings are going around the earth. So here latitude is the imaginary line that run around the earth horizontally, and remember that these lines are parallel to each other. Now in the right hand side you can see longitude. Longitude is imaginary line that runs around the earth vertically, that is from up and down or down and up, and it meet at the north and south pole. Now we know that on the top it's the north pole and downwards is the south pole. So just now you saw different locations of the sun during the day and changes occurring in the shadow. So now here let us see again. Here the position of the sun decides the length of the shadow. In the morning, the length of the shadow was greater, and as it was noon, the shadow was hardly visible. And again, when it is evening, the shadow again increases. So here, as you can see that the shadow during morning and in afternoon, the length of the shadow was greater as compared to the shadow which was there in noon. The noon time is the same at any given longitude across the earth, that is from North Pole to South Pole, and therefore the time of a place as decided by the location of the sun in the sky is known as local time. So students, from this video we learned the earth takes 24 hours to complete one rotation. The earth rotates from west to east. Due to the rotation of the earth, we feel that the sun is changing its position from east to west daily. The shadow in the early morning and evening are longest, and the shadow in the noon is the shortest. Oral activity. So students, here you have to answer the questions orally based on the video. From sunrise to sunset is dash, and from the sunset to the next sunrise is dash. Dash was used to tell time. This is our earth. This is the equator. This is North Pole and this is South Pole. Now let us move to the North Pole. Now this is the North Pole. Now you can see a yellow color circle over here. So this is called as polar circle. The polar circle, which is at the North Pole, is also referred as Arctic Circle. Now, let us move towards the South Pole. Now here again you can see a yellow color circle. This is also known as the polar circle. The polar circle, which is at the South Pole, is also referred as Antarctic Circle. So, in the regions lying in between the polar circles and the poles, the daytime could be more than 24 hours, depending upon the season. As a result, understanding the time of sunrise, noon, sunset and midtime at these places become very important. At the poles, the daytime and the duration of the day last around 6 months. To tell the time of sunrise and sunset, the one has to consider date. So the region that are lying in between the polar circle, they experience 6-month day and 6-month night. The earth takes almost 24 hours to complete one rotation, that is 360 degree. We all know that earth takes 24 hours to complete one rotation, which is 360 degree. The earth rotates by 360 degree in 24 hours. So let us divide 360 degree by 24 hours, which is equal to 15 degree. So the earth takes 1 hour to cover 15 degree. The earth takes 60 minutes to cover 15 degree. Now let us divide 60 minutes by 15 degree. So the answer we get it as 4 minutes. So the earth takes 4 minutes to cover 1 degree. This means that for each degree of longitude, the local time differs by 4 minutes. Okay, so now this is the world map along with the degrees of longitude. This is 0 degree and this line is the prime meridian. Now here the difference between 0 degree and 15 degree is how much? 15 degree. And we know that the earth takes 1 hour to cover 15 degree. Now let us come here. 15 degree and 30 degree. Now again the difference between these two is 15 degree. So again from 15 degree to 30 degree it will need 1 hour. Now if we take from 0 degree to 30 degree, the distance to cover will be how much? It will be 13 degree. So it will need 2 hours to cover this much distance. So now, the longitudes lying to the east of the prime meridians are ahead of the time. And the longitudes that are lying to the west of the prime meridian are behind. As we know that the earth takes 1 hour to cover 15 degree. So, if we move 15 degree east, we will be 1 hour ahead. And if we move again 50 degree east, then we will be again 1 hour ahead. And similarly, we will be 1 hour ahead if we move 15 degrees towards the east. Similarly, if we move towards the west, we will be 1 hour behind. And similarly, as we move 15 degree west, we will be 1 hour behind. So now for example, if it is 12 noon at 30 degree east, what will be the time at 90 degree east? So let us count. From here it will be 1 hour, 2 hour, 3 hour and 4 hour. So from 12 noon to 4 hour it will be 4 p.m. So the different longitudes have different timings for sunrise, noon and sunset. Take for example Mumbai and Kolkata. If it is noon at Mumbai, it won't be the same at Kolkata because as we can see in this picture that Kolkata lies to the east of the Mumbai. And previously we learned that if the place is lying toward the east, then it will be ahead. The time will be ahead. So if it is noon at Mumbai, it will be already afternoon in Kolkata. There is no difficulty when local time is used for small areas. But when people living in a larger area across different longitudes have to interact with each other, then using the local time could lead to chaos and confusion. So in such case, using the local time is not convenient. So from this video we learned the noon time is the same at any given longitude across the earth. The time of a place as decided by the location of the sun in the sky is known as local time. At the poles, the daytime and the duration of the day last around 6 months. And as we move towards the east of the prime meridian, the local time increases by 4 minutes for every longitude. Oral activity. So you have to orally answer this question. The local time of a place on the Earth's surface is determined with reference to its dash. Try this. This activity is on page number 3 of your textbook. The local time of a place can be calculated with reference to the time at prime meridian. Examine the examples given below. Example 1. Mashhad, a town in Iran, is located on the 60-degree east longitude. When it is 12 noon at Greenwich, calculate the local time of Mashhad town. We all know when it is 12 noon at Greenwich, the Greenwich is located at 0 degree. So, the statement will be, as we move towards the east of the prime meridian, the local time increases by 4 minutes for every longitude. Next step, the difference between the longitudes of Greenwich and Mashhad is, we all know Greenwich is 0 degree and Mashhad is located at 60 degree east. So, the difference between these two places is 60 degree. Now, difference in local time. We all know that local time increases by 4 minutes for every longitude when we move towards east. So 60 multiplied by 4. The answer we get as 240 minutes. So now in 1 hour, how many minutes are there? There are 60 minutes. So 240 divided by 60 minutes. The answer we get as 4 hours. So the answer will be, it implies that the time at Mashhad would be 4 p.m. in the evening. Now, why 4 p.m.? We know that as we move towards the east, the local time increases. So here, if it is 12 noon at Greenwich, we have to move 4 hours ahead of Greenwich time. And so, it will be 4 p.m. in the evening. Example 2. Manaus city in Brazil is located on 60-degree west longitude. What would be the local time at Manaus when it is 12 noon at Greenwich? So the statement will be, as we move towards the west of the prime meridian, the local time decreases by 4 minutes for every longitude. We all know that Greenwich is at 0 degree and Manaus, the location is 60 degree west. So again, the difference between both the places are 60 degree. So total difference in time, it will be 60 multiplied by 4. The answer we get as 240. Now in 1 hour, how many minutes are there? 60 minutes. So 240 divided by 60 minutes. And when we divide, we get the answer as 4 hours. So now here it is clearly seen that Manaus is 4 hours behind the Greenwich time. So here we have to go 4 hours behind. When it is 12 noon at Greenwich, move 4 hours behind. So let us write the final answer. At Manaus is located to the west of the Greenwich. The local time of Manaus is behind of Greenwich time by 4 hours. And therefore, when it is noon at Greenwich, it would be 8 a.m. at Manaus. Now, can you tell? This activity is on page number 3 of your textbook. We have studied that the local time is different in different parts of the world. The daily routine of the people there is determined according to the local time in those places. Figure 1.3 shows the local time of different longitudes. Study this map and answer the following question. Use the relation between degrees and time of this. So here, this is the map, that is figure 1.3. It is on page number 4 of your textbook. So now let us solve the first question. Question number 1. Between which longitudes does the region experience daytime? So now, as we can see, down from here, it is sunrise, then noon, then sunset. So means that these longitudes are experiencing daytime. Now let us see these are which longitudes. It is from 90 degree west longitude to 90 degree east longitude. So the first answer is between 90 degree west longitude and 90 degree east longitude, the region experience daytime. Question number 2. Which longitudes experience noon and midnight respectively? So here noon. Now which longitude is experiencing noon? It is 0 degree. So 0 degree longitude is experiencing noon. And which longitude is experiencing midnight? See, first midnight is over here. So it is 180 degree east longitude. And even here is midnight. So that is 180 degree west longitude. So second answer is 0 degree longitude experience noon, 180 degree east longitude and 180 degree west longitude experience midnight. Question number 3. Edward from New Orleans is on which longitude? So let us refer to the map now. So here is New Orleans. So answer will be Edward from New Orleans is on 90 degree west longitude. Answer 3 is Edward from New Orleans is on 90 degree west longitude. Now next question. What is the time at Accra City? So here is the Accra City. And what is the time? Let us see. It is 12 noon. So the time at Accra City is 12 noon. Answer 4. The time at Accra City is 12 noon. Question number 5. At the same time, what is Sharath from Patna and Yakaito from Japan doing? What time is it in these cities? So let's go back to the map. In India, Patna is here. So it is around 5:30 p.m. at Patna. And let us go to Tokyo. Tokyo is here. It is around 9:20 p.m. at Tokyo. So in Patna, it is evening and Sharad is going back home from school, as we can see in the picture also. And in Japan, it is night. So Yakaito is going to bed. So answer 5. In Patna, it is evening. Sharad is going back home from school. And in Japan, it is night. Yakaito is going to bed. Now question number 6. Select any one longitude. Calculate the local time of the longitudes lying 1 degree to the west and east of this longitude. So now here we have to select any 1 degree longitude and we have to go 1 degree back, and that is 1 degree to the west and 1 degree to the east of it. So let us take 60 degree east longitude. What is the time at 60 degree east longitude? It is 4 p.m. So if we take 1 degree to the west of the 60 degree east longitude, it will be 4 minutes behind. That is 3:56 p.m. And if we take 1 degree to the east of 60 degree longitude, it will be 4 minutes ahead. So it will be 4 hours, 4 minutes. So our answer will be at 60 degree east longitude, it is 4 p.m. 1 degree to the west of 60 degree east longitude will be 3:56 p.m. And 1 degree to the east of 60 degree east longitude will be 4 hours, 4 minutes.